Hi everyone, my name is Igor Nunes Patricio, and together with Kyle and Carlos, we trained the deep neural network model known as EOLO to detect underwater crown of thorns starfishes in videos and images. Outbreaks of COTS, as the species is known, have caused a lot of damage and mortality to coral reefs. Due to that, scientists have put a lot of effort in monitoring and maintaining the equilibrium of reefs, a task that can be definitely easier with a real-time object detection system like EOLO. So our challenge is to train a YOLO v5 model and accurately predict COTS in real videos and images, like the image on this slide. So to train the model, we need a dataset with lots of images and COTS instances everywhere on these images, and also from every size, because the more general the dataset, the better our model can make predictions. We then choose a Kaggle competition dataset with underwater frames from 3 separate videos. While there is an average of 7,800 frames per video, 79% of them did not have any instance of COTS. Another problem is that since they are frames from videos, there is a high similarity between sequential images, failing the idea of a general dataset. Also, the majority of frames have small instances of COTS, failing the idea of a general dataset too. So we separate the frames from video 1 as training data, the frames from video 2 as validation data, and the ones from the video 3 as test data. We decided to perform a base train on frames from video 1 and then added some steps to improve predictions. First step, we did some data selection and augmentation on frames from video 1 in order to generalize the dataset. Second step was to increase the image size on training to 2400 pixels, since this increases the information base passed to the model. Third step was to add a new dataset with bigger instances of COTS to make the dataset even more general. The partial results on the validation data are shown on this table, as well as the same image from the previous slide with detection after the 3 steps were done. And for the final results, we trained the model on the train and validation dataset and perform metrics on the test dataset. These images that you see on this slide are from the test dataset. We also rebuild the test video and post on YouTube. You can access the video by clicking in this first link here. And another video that we show qualitative results can be seen on this other link. It was a random video that we used to perform detection. The good thing is that since this is a random video from YouTube, there's no relation with the dataset used, and the model seems to be performing really well.